All right, so we're going to be going through section 7.5. This will be one of the sections that we will be covering on Wednesday of this week, which will be April the 1st. So this is area between two curves. So in order to do this, what we're going to do is it's very similar to what we've already been doing. In fact, we've really already been doing this. So if we let f of x and g of x be continuous functions and suppose that f of x is greater than or equal to g of x, over the interval from a to b, then the area of the region between the two curves from x equals a to x equals b is given by the interval from a to b of f of x minus g of x dx. Now, if you notice in this case right here, we can see that f of x is on top and g of x is on bottom. In general, a lot of times we do not care which one's on top, which one's on bottom, because we can actually figure out which one's on top and which one's on bottom based off of our final answer. There will be some cases when we're not given the endpoints of where these two curves meet and everything that we might have to worry about that. But our ultimate goal is we're trying to find this area right here. So, how do we do that now? So, let's think about this example right here. So, notice in this case right here, they give us the graph. It says find the area of the region that is bounded by the graphs of f of x equals 2x plus 1 and g of x equals x squared plus 1. So first, we need to determine where they intersect. Obviously, if we're given the graph, it's real easy. If we're not given the graph, which we could easily figure out in this case, you take the x squared plus 1 equals 2x plus 1. You set them equal to each other. Get everything on one side. You get x squared minus 2x equals 0. Factor out an x, so x times x minus 2 equals 0. That gives us x equals 0 and x minus 2 equals 0, so x equals 2. So x equals 0, x equals 2. Well, that's the 2 points they gave us, 0, 1, and 2, 5 as our two x coordinates. So this is if our endpoints are not given because we had to find them. So the next thing we can worry about, so there's our process there of figuring out where they intersect at. It's the same one that the same way I actually just did it. So next we want to compute the integral. Does it matter which one's on top? No. In this case, we picked that f of x was on top of g of x. So 2x plus 1 minus the x squared plus 1. So 2x minus x squared. We integrate and get x squared minus x cubed over 3, evaluated from 0 to 2. You plug in 2, you get 2 squared minus 2 cubed all over 3, minus when you plug in 0. So you get 4 minus 8 thirds, which is 4 thirds. Now, say we didn't know, say we picked it the other way. Say we did the integral from 0 to 2 of x squared plus 1 minus the 2x plus 1 dx. So this is the integral from 0 to 2 of x squared minus 2x dx, or x cubed over 3 minus x squared evaluated from 0 to 2. So you would have gotten 2 cubed over 3 minus 2 squared, which is going to give us 8 over 3 minus 4. So 8 over 3 minus 12 over 3 gives us negative 4 thirds. So notice we get the same exact value except for one's positive and one's negative. So in these easy cases, it doesn't matter which one you pick in the end because we're finding area. So since we're finding area, we only worry about that 4 over 3. So if we were to work out a different problem, negative of x squared plus 1 and 2x plus 4, In this case, we're given x equals -1 and x equals 2. So since we're given both of these values, that's our two endpoints, the integral from -1 to 2. Notice I just randomly picked them. It didn't matter which one was on top, which one was on bottom. So negative of x squared plus 1, and then minus the 2x plus 4 dx. So therefore, that is the integral from -1 to 2 of negative x squared minus 2x minus 3 dx. When we integrate that, we get minus x cubed over 3 minus x squared minus 3x. So then plugging in 2, we get minus 8 over 3 minus 4 minus 6. Subtracting when we plug in 1. So in other words, this right here is minus of 2 to the third over 3 minus 2 squared minus 3 times 2. And then minus, we would have plugging in the -1, negative of -1 to the third over 3 minus -1 squared minus 3 times -1. So that's where we get the minus 8/3 minus 4 minus 6 minus 1/3 plus 1 minus 3. When we do that, we end up with -15. We don't need it to be negative because this is area. And so that means that our answer is 15. So what that means, whenever we get that negative area, what that means is that we have picked a value that the minus x squared plus 1 is actually below the graph of 2x plus 4. And we're saying it's the other way around when we pick this area. So that's what we have to kind of worry about there. So we're told find the area of the region enclosed by y equals x squared minus 2x and y equals x on the interval from 0 to 4. So we know when they're at 0, we get the same answer as when they are at um, at 4. So we plug in 0, we get 0, so we know they're touched there. You plug in 4, you get 16 minus 8, which is 8, and then the other one you get 4. So when we plug this in, so integral from 0 to 4 of x squared minus 2x and then minus the x dx is equal to integral from 0 to 4 of x squared minus 3x dx. So x cubed over 3 minus 3x squared over 2. Plug in 4, you get 64 over 3 minus 48 over 2. So you end up with a minus 8/3. So therefore, we need to convert that to a positive 8/3. Now, integrals are very prevalent in terms of business applications. So the equilibrium point xe comma p is the point at which the supply and demand curves are intersect. This is our equilibrium point easy. It's the point at which sellers and buyers come together and purchase and sales accordingly. So if we look at this graph, this is saying that the consumer surplus is above the producer surplus in this case. So we need some more formulas. So suppose that P equals D of X describes the demand function for a commodity. Then the consumer surplus is defined for the point Q comma P as the integral from 0 to Q of D of Q minus P. So this is our demand function minus the equilibrium value. So we're told find the consumer surplus for the demand function given by D of X equals X minus 5 all squared when X is equal to 3. So the first thing we want to do is we need to find our P value here. So we're going to plug in 3 into our demand function to get 4. So then our consumer surplus is the integral from 0 to 3, the x value that we found here, of our demand function of x minus 5 all squared minus the equilibrium point of 4 value that we found. So if we FOIL this out, x minus 5 all squared is x minus 5 times x minus 5, x squared minus 5x minus 5x plus 25, x squared minus 10x plus 25. Then we can subtract our 4 in all cases that they had on that same line. So x squared minus 10x plus 21. We need to integrate this. So by integrating this piece, we get x cubed over 3 minus 5x squared plus 21x, evaluated from 0 to 3. Plug in 3, we're going to get 27 divided by 3 is 9. 9 squared, or 3 squared is 9 times negative 5 is negative 45, plus 21 times 3 is 63. In this case, the 0 cancels out. So 9 minus 45 is negative 36, plus 63 gives us $27. So our consumer surplus for this function is $27. With consumer surplus, we also have producer surplus. So our producer surplus is defined as the integral from 0 to q, just like before. This time it's going to be the equilibrium value P minus our supply function. Because as you can see from this graph, our producer surplus is our P value is on top of our supply function. So we're told find the producer surplus for S of x equals x squared plus x plus 3 when x equals 3. So we find our y value when x is 3 by plugging in. So P equals S of 3, which is 3 squared plus 3 plus 3. So 15 would be our answer. So our producer surplus is defined as the integral from 0 to 3 of 15 minus the entire function of x squared plus x plus 3. So 15 minus x squared minus x minus 3, or negative x squared minus x plus 12. When we integrate this, we get minus x cubed over 3 minus x squared over 2 plus 12x evaluated from 0 to 3. So minus 3 cubed over 3 minus 3 squared over 2 plus 12 times 3. Or we get 3 cubed is 27 divided by 3 is 9. So minus 9 over 4 plus 36. So we end up with minus 36 minus 9 plus 144 all over 4, or 99 over 4. If we were to divide that out, hopefully we get 22.5. That answer is actually incorrect, unless I've made a mistake somewhere. Minus x cubed over 3 minus x squared over 2 plus 12x. I actually did make a mistake, so let's go back and fix that mistake. This should have been a 2, not a 4. So it should have been minus 18 minus 9 plus 72 all over 2. So we should have ended up with 45 over 2. And then when we divide that out, we get the 22.5. So we're told, find each of the following. We're given our demand is x minus 5 all squared. Our supply is x squared plus x plus 3. We're told to find the equilibrium point, the consumer surplus at the equilibrium point, and the producer surplus at the equilibrium point. So to find the equilibrium point, since we're not given any information, what we have to do is we have to set our supply and demand functions equal to each other. So x minus 5 all squared equals our x squared plus x plus 3. FOIL out the left-hand side. Combine our like, and then we can simplify the x squareds because they're the same sign. We can cancel them out. We can add our 10x across and subtract our 3 across to get 22 equals 11x. So that means that x equals 2. So we have found the x value for our equilibrium point of 2. That means now that we can either plug 2 into the demand function or the supply function to find our p-value there. It does not matter which one that we do. So if we plugged it into our demand, d of 2, so 2 minus 5 all squared gives us negative 3 all squared, which is 9. So our equilibrium point is the point 2 comma $9.